Thanks for checking out this video. This video today is setting up an experiment, our last experiment for the 2019-2020 school year. And it's about plants and um, what plants need to survive. Let me explain a little bit more. So I'm going to plant beans, just like this here. And you can use what you want, but plant whatever you have, whatever you choose. Just whatever you choose, make sure it's the same thing in each container that's growing a plant, right? You don't want to plant beans in some and tomatoes in another and grass in another. Just plant the same thing. That's one of those variables that we want to control. Um, and you can do as many trials as you want for this experiment. But let me explain that one trial in this experiment, you'll need 3 plants. So 3 plants per trial, okay? And I'm going to probably go with 2 trials here at my house and see how that turns out. If we were in school, right, I would have you in groups of 3. Each group would be a different trial, and we'd have like 10 or 12 trials right there in the classroom. And so we'd have plenty of trials. And I'll be honest, there were years where many plants didn't sprout for some reason. I don't know if we got a bad batch from the store or what happened. Last year, if I recall correctly, almost every plant sprouted and grew, so it really worked out great. So let me just warn you, if you just do one trial and one of the plants doesn't grow, then there might be a problem because you won't have enough information to answer the question that we're going to be asking here. So you might want to do a couple of trials, and if you're in contact with friends in the class, kind of communicate with each other. And if you each do 2 trials, there's 4 right there. If 3 of you do 2 trials and communicate about it, there's 6 trials. So you guys have ways of working that out amongst yourselves. So what's going to happen here is um, one trial will have plants that are getting no light. Okay, so once they sprout, we're going to put them somewhere dark. If it was at school, I would get a big old box from the cafeteria and we would store them all in that box, and they would never come out of that box except once every few days to give them a little bit of water. So there's going to be one plant with no light, uh, one plant with no water, okay, and one plant that gets both light and water. So that would be the control group, right? That's the group that gets everything, and we see how it grows, and then we compare the other two, one missing light, one missing water, to the one that gets both, and we can decide what goes on there. So what I'm going to do here is um, make a small hole in this cup of dirt, right? So what you have to do is you get yourself a container. I'm just using plastic cups. You can use flower pots, anything you have that will hold soil and water, so because you're going to be watering some of these. So I just filled it up with dirt about 2/3 of the way, right around here. And using my finger, I just make a small little hole about an inch deep, right? And I'm going to put one seed in each cup. So when I plop it in there and just cover it lightly, um, sometimes students will really push down on the dirt, packing it in. And I think sometimes that affects the plant's ability to sprout out of the soil, right? Gets packed too tight and it can't uh, push its way through. So just don't pack it down. Just a little bit of a hole, drop in the seed, cover it up, and you'll do that in each of the 3 cups, right? So you're going to end up with 3 planted seeds. As far as dirt, just use the same dirt for each one. I happen to have a bag up in the garage that we opened, so we just use some potting soil. If you have a garden in your backyard and your parents don't mind you taking a few scoops out of it, you can use dirt from outside. That would work just great. Again, you want to control those variables. You want to make sure that whatever you're doing for one, as far as the cup and the type of dirt you're using and the amount of water that you provide, all those things you want to kind of keep the same from plant to plant to plant. Otherwise, some of those variables might cause differences in how the plants look. All right, so the goal here is to figure out what will happen to a plant that doesn't get any water, and to figure out what will happen to a plant that doesn't get any light. And I know what, like, if I just said that and we were in school and you were writing this up, um, some of your hypotheses, right? Your step three, the answer to the question, some of you would just write, oh, it's going to die. The plant's going to die. And that's not accurate enough. That's not detailed enough. So there's three things I want you to think about when formulating an answer to our question. I know I really didn't say the question yet, and I'll get to that in a second. But what you're thinking about is the plant's color, okay? What will the color look like if it doesn't get water or if it doesn't get light? Um, what will the leaves look like? Right? How will the leaves be different in this plant? This plant does have leaves. Most do, almost I think all do probably, of some sort. So what will the leaves look like? How big will they be? How many will there be? And finally, the height of the plant. How tall will it grow over time? And it doesn't matter how long. You could keep this going all through the summer if you want, right? You could replant them outside. I had students take home their plant from the school year and plant it in their own gardens, and it grew pretty wild. And they actually got some beans off of it, and it worked out great. So those are the three things, though, you want to think about: color of the plant, the leaves and what they look like, how many, how big, how small, and the height of the plant. How tall does it get? Okay. So the question then becomes something to this effect, something. How will a lack of water and a lack of light affect a plant's color? How will it affect a plant's leaves? And how will it affect a plant's height? Right? That's the question that you're thinking about, that you want to answer in your guesses, right? And you have time, you can really think about this, get some background information. Really works out great if you actually write this down. Obviously, I'm not collecting anything from you, there's no write up to turn in. Um, but if you write these things down, it'll make it more meaningful, and you'll have a better understanding once the experiment is done. Now, keep in mind, I want to explain this one more time. If you want to do a trial of this experiment, you need to plant 3 seeds, right? Once they're planted, in a minute here, I'm going to water them, right? They get all of them, even the one that says no water, gets a little bit of water when you plant the seed, right? That moisture helps the seed sprout in the dirt. So um, you water them all as soon as you plant them. And you might be thinking, well, how much water do you need? In a cup this size with one seed, just use your judgment. Ask a parent. I would probably guess around a half a cup. Just, you don't want it so there's water. You don't want the dirt floating in water. You don't want to fill up the cup with water, but you want more than just a spritz. Like, remember when we made the bread wet in our previous experiment about the mold? And by the way, my bread is not molding. I know it depends on when you're watching this video compared to when we made that other one, but um, it has been a few weeks, and they must just put too many preservatives in our bread nowadays, because it's taken a long time for mold to grow. But I'm going to keep it going. We'll see each other again next school year, or maybe I'll make a video in summer and put it up about some of the results of these experiments. Um, for sure, one more will do with results, because remember, we have the sublimation going on in our freezers with that ice cube, and there's been some good results there. We'll get to that one another day. But anyway, get back to this. You want to make sure you add, enough water to moisten the soil, but not too much. And once you water all 3, they all just sit out. Just put them on a shelf, put them on a windowsill until they sprout. Once you see the plant coming up out of the dirt, that's when you take the one and put it in a dark spot, right? The day you see it sprout out of the dirt, you put it in a dark spot. Um, as soon as you see the one with no water sprout, then you do not give that one water again, right? I don't think you'll have to water it twice, but maybe you might have to add a little bit of water to the one with no water to get it to sprout, but probably not. Once you water it once, give it a week, see if it sprouts. And of course, the one that gets both light and water, that one will sit out in the sunlight next to the one that gets no water, right? Because you're going to have the one that gets both and the one that's going to get no water sitting out in a lighted place, so they both get light. Just remember not to water the one that's not supposed to get water. And remember to go to your dark spot, wherever that is. If you put it in a closet or a tall box, make sure you're watering every couple of days. You add a little bit of water to the one that's in the dark, right? Because you want to make sure you keep those variables consistent, right? One of them gets both water and light, one of them gets no water, and one of them gets no light. But again, not until they sprout. Until they sprout, they get watered and they all sit out in the sunlight if you can, because I think the warmth of the sunlight heating the soil helps with germination, helps with the sprouting of the plant. So it's all the same until they sprout. That's when you break them up into their three groups and you keep the light off of the one and you stop watering one and keep giving both to the third. And that's about it. Once they're planted and watered, you're good to go. And it's going to take a little while. You know, whatever plant you decide to plant, I'm planting beans. This says they should. It takes about 7 to 10 days. It says on the package before they'll sprout. So if after a couple of weeks they're not sprouting, I might want to start over, right? There might have been they're not going to sprout. Who knows? You never can tell. That's the good part about doing more than one trial, right? You have several trials going, and you can see if one of them is sprouting, you could count on that the other one should be sprouting too. And if they're not, maybe they're never going to sprout. So that's it. Get them planted, get them watered, and as soon as they sprout, put that one in a dark place, stop watering the other ones, or stop watering the one group, and make sure the control group, the one that gets both, does get both. And you should see some pretty specific results. This is one of those experiments that it takes a while, right, before you get real results. We typically start this right before spring break, and then we get back after that long week off, and they were sprouting before then, typically the way I would set it up. And when we get back, you'd see a real clear indication of the results, because you didn't get to see them for a whole 10 days or so, and we'd come back to school, and you'd tell real easy how water and light affect. The one other thing I want to mention is that this process that plants use to make their own food, I'm sure you guys have heard of this. It's called photosynthesis. They use water, they use sunlight and air, right? Um, Lucky for us, when we exhale carbon dioxide, plants use carbon dioxide and they give off oxygen. We take in oxygen and exhale carbon dioxide, right? So we're great for each other. Animals and plants really keep each other alive in that way. But that photosynthesis has those three ingredients. And we're not, you might be wondering then, well, why aren't we testing no air? How come we're not going to have a plant group with no air? And to be honest, it's not as easy to have no air. You really have to have no air if you're going to have no air. You can't just put it into a Ziploc bag and seal it, because what's that bag full of? Air. And we just don't have a great way to actually take all of the air out of an environment for the plant to live in. So that would be interesting, and that might be something that could be worked out some way. But for our purposes here, it's a lot easier to just keep one in the dark and not water one group of plants. Um, but who knows if you have some way of creating an environment, and then how do you water it, right? Like how do you get into like, even if you could take the air out of a container and keep the plant in there, how would we get into the container to water it without letting air in? So it's a lot trickier to have no air as one of the environments. But those are the three ingredients, or three things that a plant uses when creating its own food through photosynthesis. All right, I think that's it. I hope I'm not forgetting anything. If you think of something, or if there's something obvious that I did not mention that you're like, hey, how are we supposed to do this? Just comment on the video, and ask that question, and I'll be happy to get back to you. Send me an email. You guys have my email. It's on our Google Classroom, of course, or you could just go to the Burdick website and click on staff, and you can send me a message. We're on the Remind app, right? There's lots of ways to communicate here, guys. So if you have a question, please ask. And otherwise, I think we're good. And thanks for watching. Again, I think this is the last one we're going to do, last experiment we're going to set up for this school year. So, all right, take it easy, guys. Thanks.